Hello, let's continue our Sudoku adventure with 6 of 1 by Strosahl. So we have normal 6 by 6 Sudoku rules. That means in each row, each column, and each 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have little killers. So what you do is you take the diagonal arrow and you follow it to the other end of the grid. And all of those cells that it points at will sum to the digit. So these 3 sum to 7. These 3 sum to 7, these 3 sum to 5, etc. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I'm looking for what might be the most restricted thing. I mean, these two just add to 5, and we know they don't repeat because they're in the same box. So it could be 1 plus 4, it could be 2 plus 3, but it's not 5 or 6, I guess, is the important thing. 5 and 3. So the way to think about this is in this box, it could be a 1-2 pair. Obviously can't do 1-1 within the same box. So that would add to 3. And this could be a 1. And so 1-2-1 would be the absolute minimum. And that adds to 4. So that means we need to add 1 to this. So we're either going to be a 1-3 pair here, adding to 4, or this is a 2. But this always contains the 1. This 5 is the same. So 1, 2, 3, 1, 2, and this always contains the 1. All right. Does that affect anything? So 7, I mean, again, so this is, oh, interesting. Okay. Oftentimes combining sums can give you a much better deduction than taking them on their own. So this is kind of a classic way to combine them. Notice that this is the only cell that's not fully within this box. So what we can do is we can say, well, we know that the green cells must add to 5 plus 7. So they add to 12. But we also know that these 4 cells add to a minimum of 10. If they were 1, 2, 3, 4, they would add to 10. And then this is a minimum of 1. So 1, 2, 3, 4, and 1 here would sum to 11. We need to sum to 12. So we need to add 1 to this. So we're either adding 1 to here, making it a 2, or we're including a 5 in here. But this has to use 1, 2, 3. We know the 5's not over here because it adds to 5. So this contains 1, 2, 3, and it's missing either the 4 or the 5. And so the 6 actually can only go here. If we tried to put a 6 up here, the absolute minimum we could do is 1, 2, 3, 6, which is already 12. Okay. Yeah. And so the 6 has to go here. And then this is either the 4 or the 5, whatever was missing from these 4. Notice I did make a 1-2 pair here, so this is only 3. Sorry, this is opposite. This is only 3, 4, which means this has to be 1, 2 in order to get us to 5. All right. And think about it this way is much cleaner than trying to think, well, this actually can't be 1, 2 because then that breaks the 5. It also can't be 1, 3 because that breaks the 5. So it has to add to at least 5 at 1, 4. And just making this add to 10 at least is the same deal. All right. This 6 looking down, the 6 is in one of these two and one of these two. All right. So I have a 1-2 pair here as well. But what sums actually remain here? Maybe, okay, I'm going to combine these as well because actually that's more restricted by far. 5 plus 6 is 11. So these need to add to exactly 11. So this is still 1 or 2. And so, oops, whoa. We know the 6 is either 1, 5 or 2, 4. So, but it can't be 1, 5 because the 1's over here. Okay, so it is 2, 4. Making this a 1, 3 pair, making this a 1. Okay, that works. Okay, that worked itself out without needing to combine. So that's a 5. That is not a 5. So we get the 2 here, meaning that these need to add to 10, these need to add to 11. These need to add to 11 in order to get to, no, what am I talking about? This adds to 12. 5 plus 7 is 12. So these have to add to 10. Right, because this ended up being 2. Yeah, that's 10. Why did I think there was a degree of freedom for 11? There wasn't. This had to be 1, 2, 3, 4 with a 1 there. Sorry. I think I was thinking about something wrong there. But anyway, we still got the correct answer. So this adds to 10 as well, meaning it doesn't have the 5. So that's our 5. That's 1. I mean, with the 2 here, I could have just said this adds to 5 and that adds to 5. So that's our 5. Anyway, there's a lot of things I could have done. I'm getting there. We're solving it. This is 3, 4, 6. So what's next? That adds to 6. That adds to... This adds to 5. We have this 5. We know this is 1 now, so this has to add to 4. So it's a 1, 3 pair. Meaning the 3 is not here, so the 3 is up here, making this a 2 to add to 5. And this is now a 1, 4 pair to get us to 7 there. That gives us the 4, 2 here, and the 1, 3, and the 1, 4. Okay. We get our 3, 1 resolved down here. And this is 2, 5. The 2 tells us that's 5, that's 2. So this is a pair. This is a 3, 6 pair. This is a 4, 5 pair. This is a 3, 4, 5. This cannot be 3 or 5, so that's a 4. All right, that gives us the 6 and the 4. Okay. These 2 digits are the 1 and the 2. The 1 tells us that's 2, that's 1. These are 3, 5, 6. This can't be 3 or 5, so that's 6. This is 3, 5. Oh, I have this 7. So it has to be 3, 3, 1. It has to be the minimums. So that's 5. That's 6 and 3. Didn't notice that I still had little killers to do. So this is 2, 4, 5. This can't be 2 or 4. So this is 5. That's 4. That's 5. So this is 2. And then up here we need 4, 6. That's 6. That's 4. Okay. Nice puzzle, Strosahl. I enjoyed that. I probably should have started over here. This was forced. Had to be 1, 2, 3, 4 with a 1 there. And then the 1, 2, 3, 4 actually resolves for that reason. There's only one way to get this to add to 6. And this to then add to 4. And then over here, because this is a 2, this also then had to add to 10. That's a clear opener. And I just kind of fumbled around until I eventually saw it. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.